Hi everyone, myself Amulya. I am studying MPCS first year. I came from TTWREIS Jangam. Today my topic is linear data structures with C++. So everyone has a doubt in their minds why we need to study the data structures and what is it and how it will help us in our real life. So that's what my presentation is all about. I clear all the doubts about the linear data structures. And everyone has thinking that why we need that, what is the importance that also. And I'm going to give an idea on the linear data structures and how it will help us. So in general life we will take some examples. So everyone will in the general life we all play the cubic game. That means we all play and try to match the colors of the cube, and we all follow the different types of steps to color the cube. But there are some specific logical steps to solve the cube. Is the problem have one solution? No, there are many solutions for a problem. To implement that solution, we'll follow the different various data structures. So in that based on the time complexity and space complexity, we will pick the best solution. That means the total time we require to solve the solution and the total space we require to solve the solution. Based on that, we will pick the best solution for a problem. So in the next one, we are going to discuss about why we need the data structures. So the data structures is not completely a theoretical part, but it has a great practical importance and experience on us, and everyone thinking that why we need that. So I am going to explain that also. In every applications like programs and software systems, we use the data structures. That is, the programs are consisting the two major parts, data and algorithms. So algorithms tells about how data can be manipulated, while the data structures tells about how the data can be stored in the memory. And algorithms describe the way of the data to be transformed, and the data structures, learning the data structures will make the algorithm much simpler, easier to maintain and often useful. So in the picture we observe that without the data structure how the algorithms are there, and without the data structure and algorithm, with the data structures and algorithm how we are performing the programs. In the left picture we observe that the things are arranged in a not arranged in a proper manner. That means by not easily we will get the things from that. And in the right picture we observe that the things are arranged in a proper manner, so that the thing which we require will get easily. And the next slide we are moving to our main topic, data structures. So the data structures deals with the study of how to organize the data in the memory and how efficiently it can be retrieved and manipulated. So the data structures are mainly categorized into two types, that is primitive data structures and non-primitive data structures. Primitive data structures are defined data structures. The integer, float, character and pointer comes under into the primitive data structures. Integer is nothing but a numeric value, that is 2, 3 or 24, 27, whatever the numeric value. It will take the 2 or 4 bytes of memory depending upon the processor. And the float value, which is consisting the decimal part, that means 2.25 and 3.45 etc. And the character is the thing which will consist the single letter, that is whatever the letter, and it will take the 1 byte of memory. And the pointer will store the address of a variable. So even though it is storing the address of the variable instead of the single value, it will be considered as a primitive data structures because it will take the only single block of memory. And when we are moving to the non-primitive data structures, it is the group of data elements or collection of data elements. Arrays, lists, files will come under into the non-primitive data structures. So without the primitive data structures we can't create the non-primitive data structure. With the help of the primitive data structures only we will perform the non-primitive data structures. We are going to discuss about the arrays, lists, files. The arrays are the data structure which will take the similar type of data elements. That means they will store in a continuous memory allocation. So, as it is the type of static memory allocation, once the memory space is defined, it can't be changed during the runtime. So, we need to define the maximum memory size before using the arrays. So, and the insertion and deletion operations are very complex in arrays because it needs the data shiftings, and if we define the maximum size of array and if we use the less memory from that, it leads to the memory wastage. So, that's about the arrays, and we are moving to the list and files. And file is a collection of record, and primarily files are used to organize, manage, process and retrieve the data. So, as it takes the large amount of data, so we need to take the help from the secondary storage devices, and we are moving to the lists. Lists will support the dynamic memory allocation. That means once the memory size is defined, it can be changed during the runtime. And the lists are categorized into two types: linear data structures and non-linear data structure. In the next slide, we are going to discuss about these things. So, linear data structures will contain the data element having the one unique predecessor and successor. So, and the non-linear data structures will having the, based on the structure, they will decided as the non-linear data structures. The data element having the two or more successor and predecessor. Arrays, stack, queue, linked list will comes under into the linear data structures, and trees, graphs will comes under into the non-linear data structures. In the previous slide, we discussed about the array. So, in the further slides, we are going to discuss about the stack, queue, linked list, and because our main topic is linear data structures. So, in the next slide, we are going to discuss about the stack ADT. So, ADT is nothing but abstract data type. So, the algorithms or data structures having the two parts, that is, one is implementation and interface. Implementation is hidden by the user, and the interface will be chosen by the user. The stack is a linear type of data structure. It may be implemented by using the arrays or linked list. If the stack is implemented by using the arrays, the features of the arrays will be applied on the stack. So, that we are performing the stack with the arrays, and it will simply follows the last in first out algorithm. That is, the last added element will be accessed first. From the picture, we observe the example, the stack of trays and stack of pennies, stack of shoe boxes, stack of neatly folded shirts. From the picture, we observe that these things we will observe in our daily life, like in the hotels, shopping malls and in our homes also. So, the things are arranged in a stack format. And then we are moving to the basic operations of the stack. That means which operations we are performing on the stack. First, we are creating the stack with defined size. I'm saying that with defined size because the arrays are implementing by the arrays. Stack is implementing by the arrays. So, next, pushing the element, that is insertion of the element onto the stack. If we want to insert an element or add an element into the stack, we call for the push operation. And pop, that is deletion of the operation. To remove or delete an element from the stack, we need to call for the pop operation. And the get top method will return the value which is at the top of the stack. It doesn't delete the element, but it only returns the value which is at the top of the stack. And the isFull condition check whether the stack is full or not, and isEmpty condition check whether the stack is empty or not. So, these are the additional operations when we perform that while we are adding and deleting the elements from the stack. This is about the stack ADT, and next we are going to discuss about how we are going to insert an elements into the stack. First, the stack is empty. We are observing the stack with the maximum size of 3, and we are now, if we want to add an element to the stack, we have to check with the condition is full, because the stack is full, we are not able to add or insert an element into the stack. So, with defined value, we are inserting the value into the stack. So, now the empty stack, I am going to add one element into the stack with the value of 5. So, now the element is added into the stack and the top will be increased by 1. When the stack is empty, the top value is equal to -1. Now the element is added, which is 5, and it will take the bottom position of the stack. So the top will be increased by 1. And there are two more memory blocks. So I am adding the next element, that is the 10. So in that the top will be increased by 1. So the data element which is added second one will take the place above the first element. And next I am going to add the third element, that is 24. Then the 24 element is added and the top will be increased by 1. We observe that these three elements are inserted by using the push operation. And now the stack is full. Even though the stack is full, I am adding to, if we wish to add the more elements into the stack, then it will leads to the error message stack overflow, because if the stack is full, we can't able to insert more elements into the stack. Like this, we will able to add the we will insert the elements into the stack. And the next slide we are going to discuss about how to delete the elements from the stack. In that we observe that the stack is filled with the 3 elements, and if we wish to add delete the elements, we call for the pop operation. Before going to that, I want to discuss about the get top method. So get top method will returns the value which is at the top of the stack. So if I call for the get top method, it will returns the 24 value, because it is the third element which is at the top of the stack. So the value of third element is 24. So if I call for the get top method, it will returns the 24 value. So next we are going to discuss the deleting the elements from the stack. If we want to delete the element from the stack, I want to call for the pop operation. So if I call for the pop operation, then the third element will be deleted. So here we need not to give the value of the data element. The topmost element will be deleted. And next I am deleting the second element, then the top will be increased by 1. So in the next one I am deleting the third element, that is the number 5. If I delete the last element, the top will decreased by 1. So that means the stack is empty now, the top equal to -1. Even though I am trying to pop the elements, that means delete the elements from the stack, it leads to the error message stack underflow, because there is no elements in the stack. In the next slide we are going to discuss about the applications of the stack. In our real life we are using the many text editors like to perform the task. In that we are taking the help from the undo, because if we want to load the previous page or if we want to step backward, we need the help from the undo operation. So in picture we observe that at the green icon which is loading the previous page, and the next one is text editor page. In that one we are seeing the blue icon, that is undo. By doing the undo, we will step backward in the text page. And the stack will be used in language processing, that we are using the many variables, local variables and the parameters in our programs. The memory space will be allocated by using the stack only, and it will support the recursion and it will help us in matching the braces also. And if we want to if we want to evaluate the postfix and prefix expression, we need the help from this stack. And now we are going to see from the picture, that is we are the game maze game. Now some we will play as like in the phones. So in this picture the mouse has to find the path to the cheese. So if it choose the path in wrong direction, it has to face the dead end. So it has to choose the best path to reach the cheese. So that if we choose this path, it has to face the dead end. So it has to come back to the junction and it has to change its path. So in backtracking in the backtracking in the games, we will use the stack operations all. And this is about the stack. And next we are going to discuss about the QADT. So Q is also a linear type of data structure which follows the FIFO algorithm, that is first in first out. That means the element which is added in first will be accessed first. And it is here we will see the best example in the picture. So one thing about the data QADT, that it has two ends. One end is called the rear part, and the second end is called the front part. From the rear part we will do the insertion, that means adding the elements, and from the front part we will delete the elements from the queue. So from the picture we observe that the people are being in a queue to use the resource. So this is the queue, this is the front part, and this is the rear part. The people are adding in the queue from the rear part, and after using the resource they are removing from the queue from the front part. So next we are going to discuss about the basic operations and specification of the queue. So the basic operations of the queue is, first of all we have to create the queue with defining the size, because the queue is also implemented by using the arrays or linked list. So next the operation is enqueue, that is the insertion of element into the queue. That means if we wish to add the element into the queue, we need to call for the enqueue operation, and if we wish to delete the element from the queue, we have to call for the dequeue operation. So and we discussed about the get top in the stack. Like that we have the peek method in the queue specifications, because if we call for the peek operation, then it will return the value which is at the front of the topmost element at the front, and if the is full condition will check whether the queue is full or not, and the is empty condition will check whether the queue is empty or not. So these two also additional operations which we perform while adding or deleting elements from this queue. And the next we are going to discuss about the enqueue, that is inserting the elements into the queue. First of all we have to create the queue. That means we are observing from in the picture or on the screen, there is a queue with 3 data elements, and which is one block is empty. First step we have to check that queue is full or not, because before adding the elements into the queue we need to check with the condition is full, because the queue is full. If the queue is full, we are not able to add the elements into the queue. For that purpose we need to check with the condition is full. If the condition is satisfied and the queue is full, it leads to the error message queue is full. If it is the not full, or is there any empty blocks in the queue, we will be able to add the elements into the stack. And here we observe that A, B, C elements are in the queue. So and now I am adding the fourth element, that is D. So if the queue is not full, I am added the D element, and the rear part is incremented by 1. So I successfully added the element D in the queue. So in the next slide we are going to discuss and we can see how we can add or how we can delete the elements from the stack. So before deleting the elements from the stack, we need to check with the condition empty is empty, because it checks whether queue is empty or not. If the queue is empty, we can't able to delete the element from the queue. So if the queue is full, so we can able to delete the elements from the queue. Now we observe the picture that 10, 20, 30 and 40 data values are present in the queue. Now I am able to delete the element from the stack. If I delete the element from the stack, or if I call for the dequeue operation, then the front element will be deleted and the front will incremented by 1. So successfully I deleted the element from the queue. Next we are going to discuss about the applications of the queue. That in networking, the server will commonly use the queue format or queue algorithm in disk scheduling and CPU scheduling. The task which will standing in front of the CPU will complete its task first, and in our daily life we will use the queue operation when we are passing the messages. The message sent from the sender will be received by the receiver same as it is, because if the message sent by the sender will may or may not be in order, so that it will use the IO buffers, pipes and files to send the message as it is, and it will use in graph traverser and recognize the palindrome, that means reversing the word. And now we will observe the picture. The jobs are standing in a queue in front of the CPU to complete its task, like that. And we using the printers in our daily life, that is the documents will stand in a queue order to implement or to complete their task from the printer. Then now we are going to discuss about the linked list ADT. So in before slides we discussed about the stack and queue ADTs. Stack and queue ADTs will perform the static memory allocation, but the linked list is different from them because it is having the dynamic memory allocation. Dynamic memory allocation is nothing but if we define the memory size in before, we need not to define the memory size in before, because we can change the or able to change that memory space in the runtime. So in the linked list, it is consisting the nodes that are linked with each other, and each node consisting two parts. One is the data part and another one is the address part. So in the address part, it will store the address of the second node or its successor node. This is about the linked list, and next we are going to discuss about the operations of the linked list. So in the linked list, we are going to create the linked list, and we will able to initialize the linked list, and we will insert the items to the linked list and deleting and traversing. We observe the inserting, deleting and creating, initializing in the stack and queue also, but there are some additional operations in the linked list. There are searching the linked list and making the copy of linked list, reversing the list, merging the two sorted list, and sorting the linked list using the pointers. So here we are seeing that the operations which we are able to perform on the linked list. And the next slide we are going to discuss how we can able to add, how we are going to insert a node into the linked list. There are three ways of inserting and nodes into the linked list. One is at the beginning, and the second one is in between, and the third one is at the end. If I wish to add the element 100, that is in front at the beginning of the queue, beginning of the linked list, I want to do that. I want to store the address of the second node into the address link of the first node and consider it as a head. So then it will consider as the head. The link will be continued from 100 element, and this is the head of the list, and this is the previous head will be considered as the second node of the linked list. And in the next one we are going to see how we are going to add in between the list. Now we have to traverse the list throughout, and if I want to add an 106 data element in between the 104 and 108, then I have to done that. I have to copy the address link into the 106 address link, then this connection will be done, and then I have to done that the address of the new node will be stored in the previous node. Then like we are seeing the connection between these three, so that like this we are inserting the data node into in the middle of the list. And next we are going to see that how we will add the data node into at the end. So we have to traverse throughout the list. So the null value in the address part where we can find, we have to add that element in the next of that node, so that I have to done that the link, that is I have to store the address of this node into the previous node, then I have to assign the null value into the new node, then it will be considered as the tail node, then the node will be added at the last part. This is how we are able to insert or add the nodes into the linked list. And next slide we are going to discuss about the deletion of the node. If we want to delete any data node in the list, we have to do like this. There are three types: at the beginning and the middle and the end. We are going to delete the elements. The first one, we are going to delete the head node. Then we have to choose that deleted, which we are going to delete, will be considered as the current. Then head will be assigned to the next node. Then we have to delete the current. Then it is the 104 element will be considered as the head, and the list will be continued here. Next, we are going to see that how the data node will be deleted at the middle node, in the list. So we have to do that. The data node which we are going to delete will be considered as the current, and that the previous node is this. And if we want to delete the current, I have to connection like this. So I have to do that. The address of the tail value will be, or address of the next node will be stored in the previous node link part, so that the connection will be like this, and we have to delete the current. Then the 108 data element will be deleted, and the list will be continued like this. And we are going to delete the data element at the tail part. So the tail part previous node will be 108, and we are going to delete the 110 element, so we have to consider this as a current, and we are going to delete the current first. So for that we are taking the 108 data element as a tail, so we have to assign the null value into the address of the previous node, and we are going to delete the current. Then the 110 element will apart from the list, and the list will be ended here. Like this, we are able to delete the elements from the list. In the next slide, we are going to know the advantages and disadvantages of the list. Advantages: the dynamic data structure. We already said and discussed about the stack and queue. They are having the static memory allocation, but the linked list having the dynamic memory allocation. It will store that if we don't want to define the size of the or nodes or linked list before using it. In the runtime only we will able to add or delete the elements. No memory wastage, that is, in the free blocks it will take the connections and use the free blocks, so that there is no memory wastage. And in the stack, in the array, we discussed about insertion and deletion operations are very complex, but in the linked list there is no problem, because in the previous slides we discussed how we will added the element and how we will deleted the element. For that there is easy insertion and deletion of the data in the linked list, and there is only one disadvantages of the linked list, that is need the more memory. We discussed that the data node consisting the two parts, that is data element, data part, and the next one is address part. So for that address part it needs the more memory. These are the advantages and disadvantages of the linked list. And now we are going to see how the linked list will be implemented in various applications. In the graph implementation we are using the linked list, and it is having the dynamic memory allocation. We use this in the linked list of the free block, and manipulation of the polynomial. And in the general life we are going to see the applications of the linked list, that is image viewer, previous and next page in web browser. We are observing that image viewer, we are seeing that picture, but we will able to go to the previous image, and we are able to go to the next image. Like that we are implementing the linked list in the image viewer, and we are observing here the web browser, that is we are loading the previous page also, and we will redo and undo the previous and next pages by using the linked list. And here we are using the linked list in the music player. That is, if we click on this icon, it will give the previous song. If we click on this icon, it will give the next song. Like this, we are implementing the linked list in our daily life. So that's what my presentation is all about, and thanks for giving this opportunity. And I'm giving thanks very to our secretary sir and beloved dignitaries and the principal Aruna Kumari garu, who helped me a lot, and my mentor Anusha madam garu to prepare this presentation and helped me in the lecture. Thank you everyone.